Hello, good morning, everyone. Yesterday I uploaded your midterm project. Now, firstly, I will say something about it. Thank you for your homeworks. Lots of students sent me their homework, but we have some problem about your homework because lots of students sent me screenshots. Screenshots are not acceptable. If you send the screenshot, your grade will be zero. Please aware of this. I'm waiting from your report. Please send again to me as a report, not screenshot. Screenshot or Ubuntu code are not acceptable. Okay. Please send me report. Please explain your steps, figures, etc. Your grades, if I say again, if you send me, what about the one I sent you? What about the one? What about the one? About what is your name? Shinkani. Check. I check your. No. First homework, I am waiting screenshot. If you ask me this situation, but second homework, Turtlebot, they are not screenshot. Okay. Yes, first homework screenshot. Yes, you are right. First homework only installation and ROS installation. It's screenshot. Okay. Second homework is not screenshot. Okay. I extended your first homework 2 days because I am waiting screenshot. Not screenshot. I am waiting report. Please check your homework. Okay, thank you. Now I will explain your midterm project. I upload it. Also, I upload the all course document first 8 week. Now I am. Wait me. I share application. Yes. Probably you can see your midterm project. It's your midterm project, Turtlebot simulation, but advanced Turtlebot simulation. Actually, it is not a hard. In your first homework, you learn simple steps of the Turtlebot. It's very old simulation tool. Now we will develop autonomous service robot we will design. Actually, it is easy. Why? Because we have a reference website, step by step. Okay. Now I will open this website. Do you see website? We want you to learn Turtlebot in simulation. If you see, please yes or no. Yes, good. Okay, thank you. Now, this is the good website because actually in the world, generally, all autonomous systems start with the Turtlebot because Turtlebot hardware is cheap and useful, etc. However, in our home, we have no Turtlebot hardware, but we have ROS and Ubuntu. Now, in midterm project, we will design Turtlebot simulation. Now, step by step, I try to explain it. After that, you have a 2 weeks. Uh, you will copy this step and you will learn Kinect camera application, video caching, autonomous navigation, creating map, etc. After this homework, you will be ready original sensor replacement to your hardware in the future. Maybe next year, maybe this summer, maybe internship in a company, etc. Now, we have some advantages in simulation because I need to say cost, time and experiments. Actually, in the real time experiments, we have some problems because, for example, a Kinect camera is very expensive for a student. For example, 3,000 liras, for example. Also, robot minimum 100,000 liras, for example. But in the simulation, everything free. Now, step by step, you need to read this website. I upload your midterm project, a website. Please check step by step. You have a 2 weeks. 2 weeks is a good time, I need to say you, because nearly all students install Ubuntu, all students install ROS, all students nearly install the Turtlebot first application. Your first application is 2D or 1D dimension. It's a very old system, nearly 10 years ago, maybe 15 years ago. Now we will develop very modern, complementary, also robotic system. Now this is the first step. We will know, we know the advantage of simulation, and then we will start using Turtlebot in Gazebo simulator. Gazebo can simulate complex system. It's critical and magical sentence here. Gazebo is an open source. Also, you can develop plugin with the model components. Now you can develop your own model, and then you can transfer all codes, all application to the real time. For example, you can build your own autonomous robot using this simulator. Maybe next year, maybe your graduation project, you will design your autonomous vehicle. Okay, now, next step, software installation. Probably you see step by step. If you have a problem in this screen, please write me. Now, second step, software installation. Nearly all students followed these steps in the last weeks. Probably nearly all students installed Ubuntu 14. Check these steps, Ubuntu classical installation steps. We passed this one. Testing Turtlebot simulation, yes. This is my first time. Your Turtlebot is very old, I say. Now we start Gazebo. If you write ROS launch, Turtlebot Gazebo, Turtlebot world.launch, you will see Gazebo simulator. It's 3D, it is new components, new sensor, new application. Step by step, you will try Gazebo simulator. Now, for example, we have a video, Gazebo launching. You will see this video. Yes, here we have a robot in the simulation environment. You see, now we have some object in our home. This will be our home service robot. You will create this environment using these codes in your project. And then next step, you will see first time RVs. RVs is a 3D visualization environment for the ROS. It's very important for us. Okay, now we will install RVs. Also install and launch. Yes, this is my Turtlebot as a simulation. Now, next one, image. You can test step by step image topic. RVs launching. We can check this video. Okay. In next step, we start first 3D depth sensor, RGB camera. We can install camera package. We can record the depth sensor, using depth sensor, some video, some photograph. In our Turtlebot, we have Kinect. Now, prerequisite, install ROS Indigo OpenE. OpenE package is necessary for RGB camera. You can check the active 3D sensor. Okay, step by step. Testing Kinect. You can test your Kinect. You need to see this screen in your computer. After that, teleoperation. Teleoperation, actually, you developed it. The teleoperation allows you to control Turtlebot manually with keyboard, in your first homework, you developed actually teleoperation. You can use, if you can use your mouse, your Turtlebot draw a circle, draw a square, also some random actions. In this application, we are waiting from you teleoperation in the RV's environment. For example, I'm waiting. Yes. Now my Turtlebot you see goes anywhere with the keyboard. It's not an autonomous operation. It's just a teleoperation. Okay. And then interactive markers. You see, you will create interactive markers in your term project. And then, what is it? We can check together in video. Yes, we create the markers. Yes, you can see my Turtlebot in your screen. It goes using my commands. In next step, editing the simulated world. Actually, specifying world for simulation, you will create your own. It's critical. For example, you can create corridor world like this one. For example, every student should create their own environment. It's a good option for you. Launching an empty world firstly. You can see empty world. After that, we need to edit a world. You can see here, left side in your screen, select and insert tab, bear, bookshelf, bowel, cube, sum, etc. You can create your own unknown environment. Okay. You will, for example, if you are an engineer in a autonomous vehicle company, you will use ROS. For example, BMW autonomous vehicle systems using ROS and environment, ROS and RVs. It's not a very useful tool. Okay, now this is the modification tool. Some object you can add, coffee table, dumpster, etc. And also saving a new world. This will be your new world. You can create the home, you can create a factory, you can create a anything. You can export your own CAD drawing, for example, city, apartment, road, etc. And then writing your first script. You can write your first script in the ROS. Hello world, you know it's classical. Also, you have our next course. Actually, last year's I said something about the Git system, but you can read from internet GitHub account. You will create your own GitHub account. It's very critical. It's very critical. For example, GitHub all software or open softwares are recorded in the GitHub. You can check your software version, your open source software version, sharing with the people. You need to create a GitHub account. Okay, this is important. You will clone your GitHub account for Turtlebot. After that, you will download sources. Actually, Turtlebot, ROS, Arvis, it's a clone. Any people create them, you will use only these clones. For example, Turtlebot is ready on the GitHub. It's not our crate. It's a company crate. We will use only their model, but we will develop our autonomous navigation algorithm. And then launch script. Okay, creating and modifying a script. Hello world, Turtlebot. And after that, create a copy of the Python. And then launching another script. Okay, for example, we can check using this video. Everything is clear actually. Now my robot goes to anywhere. Yes, you can see. And then actually in this project everything clear. Okay, don't forget it. Only you can follow these codes. Okay. And then creating a map. Yes, interesting points are starting. Now we are creating a map. This is LiDAR. We can see some unknown environment. We start to search it. Yes, here you can see my map. And then you can define your map. This is your home, for example. You can check your borders. You can check object. You can see in your screen, yellow one are object. And the gray side, your district. Define with your camera or LiDAR, any sensor. And then testing the new map, launch gazebo, navigation, yes. It's a critical, testing the map. I defined this object. I define my map, and then autonomous navigation. This site shows us how to use the Turtlebot with known map. I know my map now. I'm waiting from you autonomous driving, not a teleoperation. Now I can check this video. Yes, here I have a map here, like a ST. We have just a, yes, it is my Turtlebot. I navigate it. Yes, my Turtlebot is goes to obstacle. Yes, it goes. It's very simple. Now, next one is critical, going forward and avoiding obstacle. Now, we will develop obstacle detection and avoiding obstacle algorithm using by these steps. Okay. And then going to a specific location on your map using code. We have some simple terminal command, run the navigation demo, launch Arvis, run command. Here we can create my position, old value, new value, and then we can go interface. For example, another operation, taking a photo. We have a Connect camera. We can take a photo in simulation environment. We have some commands for Kinect, taking a photo using code, next step, step by step, using ROS parameter, image title, photo JPEG, recording a video, step by step. Okay. Now, for example, we can check this video. Yes, we can record a video in the simulation. It's like a real life. It's like a real autonomous vehicle. After this simulation, you can develop your own autonomous vehicle. For example, you can use Raspberry Pi and a simple camera. After that, you can build your own autonomous robot. It's very good starting point for you. Okay, following the route, it's critical. I can check this video. We have a route. We define the route. Also, we have avoiding obstacle. This is, you know, from the television, maybe you have a robot in your home for cleaning. This is a cleaning robot actually. We will develop a cleaning robot for my home, for your home, but it's just a simulation. Okay, maybe this is a good option. Multiple turtle boats. It's interesting. Yes, Roastmaster release. They will communicate together. Concert. Actually, we have a two turtle boat in the same environment. And then, for example, we can see video. Yes, we have a two turtle boat. This is a swarm. One of them is goes I'm waiting from you, like this one, video, screenshot, etc. Okay, please check these website steps. Okay, in final homework, I will give you original, your own original scenario, and then turtlebot follower. One of them follow another one, and then writing your first wrap. Wrap is the Raccoon application. Here we have a document. Maybe you can check this one, but actually these commands are necessary for your midterm project. Okay, okay. Writing your first interaction. Actually, this side is elective. Swarm robot section is elective. What you read next? Yes, you can see here are references, online references, books, community, etc. Okay, these are your midterm project. Also, in your first homework, and second homework actually, Turtleboard, some students sent me really good project. I'm waiting a good project from you. You have a 2 weeks. It's very good project for your future, for your career. Okay. Do you have any question to me? If you, so professor, for example, creating map, I will just design my own map, then we'll just talk about in the report. Yes. Creating map, I will just design my own map, then we'll just talk about in the report. Yes, you're right. You can, probably you can ask me report format, I suppose that. I am not sure. You can follow all steps in the website, step by step. Please record your own video, your own photo, own map, and then report to me. I suppose that you can ask me just talk about in the report. I don't understand actually your question, but probably you are right. So, professor, for example, creating map, I will just design your own map, yes. Then we'll just talk about in the report. No. Also, you can develop your navigation algorithm in this map. Also, your turtle boat will go as autonomously using Kinect camera, using some sensors you will see in the website. Actually, your midterm project is not hard because you have a guide. In final project, probably you have no guide. In final project, I am waiting from you, for example, your own scenario. I don't know now. Maybe I will give you MATLAB, I don't know. We have 5 weeks. Yes, do you have any question? Actually, this course is not a application course actually, you see. My first aim in this course, I'm waiting from you learn Linux, ROS, and some autonomous navigation steps. After this week, I will show you MATLAB after this week. Okay, next week we will start MATLAB. MATLAB is another tool for mechatronic system, control system, and modeling. For example, if you want to develop a drone, an autonomous driving algorithm, we need some filtering system. For example, we need some navigation algorithm. We need some models for driving dynamic. MATLAB is necessary for us. Next week, I will show you some MATLAB examples and the usage. We will start with the motor modeling and actuator sensor modeling. I have no decision about your final homework. Maybe I will give you ROS, maybe I will give you MATLAB modeling. I don't know now. Now, I know just your midterm project is a good. I'm waiting from you good project. Do you have any question? We can finish today because you need to start write your code in your computer. Okay, thank you. Do you have any question? I am waiting good project from you. Okay. Thank you, dear all. Please start your midterm project. Bye bye. You have 2 weeks.